Welcome to 5G Technology World. I'm Martin Rowe, site editor. Today we are speaking with Neeraj Paliwal and Gijs Willemse from Rambus. The company recently released MACsec 800, digital IP that engineers can design into ICs that adds security protocols to 800 gigabit per second networks. 800G is the latest in the never-ending quest for higher speed wireline networks. As wireless communications, namely 5G, pushes more traffic onto wireline networks, security protocols must keep up with that traffic in real time. MACsec 800 addresses that issue.
Let me just do a brief intro here on our side, on the technical side. So my name is Neeraj Paliwal. I am the GM for the security business. And with me here is Gijs Willemse out of Netherlands, who is our product manager / owner for all of our data in motion security products, which includes the MACsec 800 the Ethernet IP as well. So if you were to ask us what is a brief 4-line technical description, I think Gijs can do a much better job than I can in explaining that succinctly. So if I may ask Gijs, please go ahead and share high level how it fits, and then we go from there.
Sure. So like Neeraj said, I'm responsible for the data in motion IPs. So if a customer is interested in security or protecting its network with a security protocol, typically a customer looks for providers of those security IPs, and they find Rambus. And if they buy an IP from us, what they typically get is a piece of RTL that still needs to be integrated into the product of our customer. So the customer is the one that in the end makes the SoC. We provide the RTL. So we don't provide the physical product, but actually just the software package that ends up at the chip of our customer. The IP that we provide is typically interface so that it smoothly interfaces with one of the network components that already exist in the chip. So in the case of MACsec, this 800G component, we typically integrate directly with a MAC interface. So I'm not sure if that's something that you know, or how the architecture look like, but Neeraj can show some slides later on in the session today. But what we provide is a building block that integrates smoothly into the SoC of our customers, and that allows our customers to protect their networks with the appropriate security protocol.
Thanks, guys. So if I may just give you a higher level on, in addition to the technical details, basically what we are seeing in the marketplace is, because there is a lot more demand working from home as well as excess capacity on the data center that is required. Because of that, we see it's like perfect storm coming from COVID-related increase in the demand for bandwidth and activity on data center side, as well as there is a natural progression happening towards 5G. Combine that with a lot more data being pushed out to edge, primarily from multiple reasons. It could be latency, privacy reason, or it could be just because the technology is available for high speed and 5G. So because of all of that, you see more and more data center now moving towards this. And what we do with our solution is it's a standard-based solution for layer 2 network security protocol that actually can do high-speed encryption, decryption at 800 Gbps to create a solution for Ethernet. So that's what we are really launching here with the press release that we are talking about today. We can look at it multiple ways, Martin. One of the ways of looking at it, as you can see my screen, is just where exactly is this data link fitting on a 7-layer overside model. Or we can look at it from security framework point of view. How does our MACsec solution fit into the famous 4 pillars of security? For example, whether you are talking to a CIO who has a CISSP certification, or you are talking to an IT person, whenever we talk about security in enterprise infrastructure space, or even in the consumer space, we want to make sure there is confidentiality aspect, like, for example, protect the privacy for both data as well as devices. Then the integrity of that data, authenticity, you are able to confirm and attest that what you are communicating with or interacting with is genuine and authentic. And the last one is when we try to implement the security, there is a very secure implementation that would render availability almost useless. So that means while we are working on confidentiality, integrity, and authenticity, we also look at, is the device or the data available when it's needed without much latency? So if you look from the 4 pillars of security point of view, you could see how our MACsec high-speed solution fits there. And I don't need to read all the words in there, how it is implemented, but that's for you to consume and to write about. And if you have any questions, we can talk about it. So those were 2 different ways we wanted to share the use case and the product with you. And we also prepared a couple of slides, very simple slides. If you are writing an article about how high speed multi-port PHY can be secured with our solution, you could actually take your users through this block diagram, and similarly for terabit switches as well. So that's kind of the overall of what we wanted to share, in addition to what you might have seen from our press release. And that overall provides an end-to-end description, starting from any electronics engineer or networking engineer can understand the 7-layer model. Any IT or CIO can understand the 4-pillar model. And then any chip designer or a person designing data centers can understand the use cases that are on slide 6 and 7. And you can pick and choose who your audience is when you're writing these things. So I'll pause here because we have limited time. I'll let you ask questions and your interest on where you want to probe further.
Okay, well, the first question is, what kind of attacks does this product defend against? What would a hacker do if they're trying to get into a network? How would they do that, and how does the product defend against it?
Well, I'm really glad you asked this question, because we have actually a comprehensive list of attacks being prepared here that's being shown. So guys, if you may go into maybe the top few, and obviously everybody knows about denial of service, cache poisoning, and MAC flooding and those things. Maybe depending on who you ask, if you ask the networking person or the IT person would be more, hey, can somebody hijack, eavesdrop, man in the middle, and denial of service? But if you ask a networking expert, networking security, they would talk about the other, like MAC cloning or flooding or cache poisoning. So guys, do you want to take a one and maybe give an example?
Yeah, actually, indeed, you covered the 3 obvious ones. Those are at the bottom of the slide. So eavesdropping, man in the middle are by default the first 2 attacks that can be attempted. So if this 800G MACsec solution is deployed in a chip, and it protects the connections between 2 data centers or 2 sites of a corporate company network. Typically, people try to attack the line that is in the public network. So if there's communication going to the public domain, picking up the line, digging it up, and basically try to monitor the data and traffic that's going over that line is the most obvious attack. Although the speeds are high, it's really relatively easy to take the optical cable and analyze the traffic that is going over that cable. So that's the first type of attack. Second type of attack have to do with denial of service and the ARP type of attack. So that's basically sending traffic into the network to the receiver and try to mimic if you're actually somebody else, a trusted party, and using a known type of packets and known type of traffic to enter a network where you want to steal data. So that means that if you apply MACsec, you do not only protect your traffic, so you do not only encrypt the traffic, but you also guarantee that the traffic that is received is authentic, and the actual sender is the party that you the sender is actually the party that you trust. So those two types of attacks are the most common attacks that are prevented with MACsec. You will actually see similar protection with IPsec. So if you're familiar with IPsec, that's a protocol that exists already for many years, over 20 years. MACsec will do something similar. However, IPsec is not capable of scaling to the modern speeds of the internet network. So IPsec is good for 1G, 10G connections, but it doesn't scale well to 100G and let alone 800G, which is now the common Ethernet standard that has just been released. So MACsec is very suitable for the scaling that is required because of the additional bandwidths that are required with modern communication, and especially with the 5G networks that are going to be deployed.
How does the speed of the network affect the need for security? It doesn't seem obvious to me, but that's maybe just my background. Well, how does the speed affect the security?
Well, so the security itself is not affected. So the methodologies for protecting a 1G link and 800G link are still the same. However, the cryptographic protocol, so cryptographic processing, is relatively heavy for hardware. It consumes a lot of power. So a CPU, if you ask a CPU to do crypto, it will consume a lot of bandwidth. So typically, if the speeds go up, CPUs cannot keep up with the security processing, and you need to go to dedicated hardware. So already at 10G speeds, you see that dedicated hardware is required to protect all the data that is going to be sent over such a connection. So let alone 800G, there's no CPU or CPU farm that can maintain encryption speeds and line rates at 800 gigabits per second. So that is where dedicated hardware comes in play. So that your security processing does not affect the throughput of the line. And in addition, like using the Zoom meeting that we are using today, you want to have real-time information. You don't want to have latency on the line. So if you use classic algorithms like TLS and IPsec, and the CPU needs to be involved with every packet, there is going to be latency. So MACsec is deployed at layer 2 in line, so that prevents that latency, there's very limited additional latency because of the cryptography added to the data.
How much about security does the user have to know, or do your customers rely on you to be the security experts, and they take this product and add it into their product?
Yeah, that's actually not a good question. So you might come from IPsec, where deploying a VPN tunnel is not straightforward. So that's actually rather complicated to install and deploy. MACsec, in contrary, is defined to scale, but also for easy deployment. So a MACsec engine by itself is really a building block. So if Neeraj, if you can go back 4 slides to slide number 6. You can see that it's really a building block that sits between Mac interfaces. Mac interface is really a standard component in the industry. It exists in every PHY, and our MACsec IP just sits between those two Mac interfaces, like any other network component that needs to be deployed in the PHY. So our MACsec IP is just another building block in the network stack. And on the software side, the MACsec security protocol offers a very straightforward key exchange protocol. So we have a software component that can just run on the CPU of any of the network devices and exchange a key. After programming the key, there's no software involvement needed at all. So where IPsec has a lot of maintenance going on with during a tunnel setup and while traffic is running, MACsec is just exchange a key, and if the secure key is exchanged, you can program it into the hardware, and all the traffic will be automatically encrypted. And there's very limited maintenance. Only after an X amount of time you need to establish a new secure connection with a new key.
So maybe I can summarize here, Martin, to your question. I think the MACsec is a more advanced implementation of the IPsec for high speed that actually automates quite a bit of details behind secure implementation. So obviously, anytime a chip designer or system designer is working on building infrastructure, network infrastructure, as you know, they would need to be knowledgeable about security, but how exactly it's implemented inside, a lot of it, like Gijs mentioned, can be automated and details could be hidden without having to know those with this implementation.
Okay. And one last question, although it may be a large one, is can you take us through the steps that an engineer would go to implement this product, starting with, what do they get? And what do they have to do with it? And then what ultimately does it produce, or where does this IP actually function?
Let me start at a high level and then Gijs can fill in the details. So look, as we are designing chips, because this is an RTL IP, in the chip IP ecosystem, normally you have two types of IPs. We call them soft IP or hard IP. Soft IP is where we give them high-level description of what logics would look like. And the chip team goes through synthesis to convert it into transistors and netlist. Hard IP is where, imagine this is a chip and there is a GDS level hard IP that can be integrated with the final fab checks and be shipped out to tape out. So this is a soft IP product. What that means is everything a chip designer needs to insert this in their chip, including all the way up to drivers and the software that makes it live at the chip driver and firmware level, all of that, including synthesis scripts or any soft IP delivers, that's how we deliver it. So usually the consumable in here is RTL and associated scripts to make it work in EDA tool environment for a chip designer to be able to synthesize and take it all the way to tape out. Does that answer your question, or shall we go in a bit more detail?
No, thank you. That answers my question. Neeraj and Gijs, thank you for your time. I look forward to speaking to you again. And if you'd like to learn more about MACsec 800, you can find it at rambus.com. I'm Martin Rowe, signing off for now.